Hello, everybody. Welcome to the October 7th US vBrownbag. Tonight we're going to be covering Objective 8 of the VCP6-DCV exam, Configuring and Administrating vSphere Availability Solutions. Your presenter tonight is going to be Joseph Griffiths. He is at Gortees on the Twitters, and his blog is at blog.jgriffiths.org. I am your host, Chris Williams. I am at Mistwire, and I will be monitoring the hashtag at vBrownbag on Twitter, as well as the chat channel to moderate. Other than that, Joseph, I am assigning you change presenter, and there you go.
Good evening, everybody. Hang on one second. Let me make sure I get my right monitor selected here. Yeah. Can you see it, Chris?
I can. Agenda Objective 9.1, 9.2.
Perfect. That means we're online. So this evening we're going to be talking about the Objective 9 of the VCP for vSphere 6. I'm going to cover a lot of the topics. Some of this will be review for a lot of people, I imagine. But honestly, the VCP is a certification where you have to do a test, not do things. I'm also going to show you how to do it just for the sake of doing it tonight, but it's going to be a lot of concepts. Please feel free to ask the questions. Chris will interject. If I ever take a breath, he will interject. I do have a bit of a cold, so it's likely that I'll cough, and that will be your chance to get your questions in.
Everybody's got a cold right now.
Yeah, it's that time of year, isn't it? I mean, it's really bad. Everyone's hacking. Half my family's hacking right now. I sent them to another room so they didn't have to hack in our general area.
Mine too.
So let's get, yeah, it's bad. Let's get going. Basically, we're going to be talking about HA and DRS, specifically with the cluster features, not storage DRS this evening. That's another objective. So as you can see, those are pretty much where we're at. It seems to focus heavily on the advanced features, but in order to understand the purpose of the advanced features, we really need to understand the underlying architecture. So for anyone who's new to vSphere, which is pretty much almost nobody on the planet, HA, its primary job is to provide the restart of virtual machines after a compute or now a storage failure. That's a new addition in vSphere 6. And DRS's primary job is to balance workload across the virtualization cluster. So with those in hand, we're going to start out with HA. We've got a lot of stuff going on this, but essentially HA is a master-slave relationship. No matter how many nodes you have in your cluster, there is one HA master, and there are X number of slaves. The master is elected by a consensus between the group. It is elected primarily by the virtual or the ESXi host that mounts the most number of data stores. If they all mount the same number of data stores, and please tell me they do. If you don't, you might want to consider doing that. If they're in the same cluster, have them all mount the same data stores. It'll make your life a million times easier. Then the one with the highest managed object ID, which is an internal ID that VMware generates at the time of boot, becomes the HA master. Election of a new master happens when various things happen, like the old master becomes unavailable, or the old master gets put in maintenance mode, or a new host comes out of maintenance mode, or something comes out of standby. There's a bunch of different things that cause election to happen. For the most part, this is transparent to you. The primary agent that does this is the fault domain master. That's the FDM you see on there. I'll highlight it real quick here. And the communication between FDMs happens across your management network on that particular port, both UDP and TCP. The TCP communication is encrypted. Now, there is one caveat to this. Well, two caveats. It takes place across your management network. There's an advanced setting that we'll talk about a little bit later that will allow you to choose which one of your VMKNICs to use. And if you're using vSAN, it no longer uses the management network. It will use the vSAN network. So that's a little bit something to understand about it. And all of the stuff that's going on with HA is being logged to this particular log bar log, FDM log. So as you can see, there's a whole bunch of stuff the master does, a whole bunch of things slaves do. The master also does all the roles of a slave, except for reporting to itself. It automatically natively does that. So it's also a slave as being part of the master. The key component is communication between vCenter on HA or high availability and between the cluster happens to the master. And then the master reports information back to vCenter, as you can see there. One of the primary concepts with HA is the protected list. This is a text file that is stored on data stores, and the protected list purpose is to denote which VMs are protected, which VMs need to be restarted if they fail on an ESXi host. This is maintained by the master and stored on the data, one of the data stores the master has access to, and X number of slaves have access to attempt to get all the ones that have access to it. It's also communicated back to vCenter, and it can be seen in vCenter as the VM protected. VMs that are powered on when there is no vCenter, so if you connect directly to an ESXi host and power on a VM, will not be HA protected until vCenter is available, and it queries about every 5 minutes to check for new VMs and will protect them at that time. VMs that are powered off are not protected because we don't need to restart those. They just get moved over. So there's a primary concept. We got questions yet, Chris?
Nope, we're good.
All right. I want to give you guys that break. I told you I'm not going to take a break unless my mouth will keep going. It's just the way
I will interject that the fdm.log question would be a great question on the VCP6. Wink.
I will take your word for it and say that that is an excellent log to look at whenever you're doing any kind of diagnostics with HA. Now, quick item before we get into the nitty-gritty of this. HA failed to configure. If you have a machine that powers itself off or purple screens of death just dies on you, quite often when it comes back up, it will not be configured for HA. If you right-click on the host and say reconfigure for HA, it will fix it. If it doesn't fix it, it's almost always because it can't talk to the master on one of these ports. The heartbeat mechanism is UDP, everything else is TCP and encrypted. So the UDP stuff is obviously not encrypted because there's no way to really encrypt UDP.
Actually,
right,
sorry, one quick question. Graham is asking, which data store does it use? The heartbeat ones?
Good question. The answer to the question is it does not use the heartbeat data stores. It actually uses the data store that's mounted by the most number of ESXi hosts. So if all of the hosts in the cluster have the same number of data stores and the same data store, then it's going to randomly choose one and select that one and it's stored on that. It also keeps the secondary copies. There's 2 copies at all times on another data store, so there's 2 in there.
Cool.
All right, let's go to the next slide. So in order to understand HA, you have to understand 3 failure states that a host can be in, or 3 conditions that a host can be in. They are failed, isolated, and partitioned. And so let's start with failed. In order to determine that a host has failed and that HA needs to take an action, in this case the action is to restart all the VMs that that host was running on another host, the master has to stop receiving slave heartbeats every 1 second. So what happens is every slave is going to send a UDP message to the master every 1 second saying, I'm alive, I'm alive, I'm alive. If that stops, then the master is going to go out and try to ping that host. This is the master reaching out. Until then, the slave was reaching out to the master. If it is unable to ping the host, then it is going to check the data store for liveness and find that it's not alive. This comes into the question that was just brought up, the data store heartbeat. So this is a critical concept that was added in 5. It was a huge improvement over 4 and continues to be a really big improvement. So what happens is every host has a file on the data stores, and the number of data stores we'll talk about in a minute, inside of a directory called .vSphere-HA that is named host some unique ID-HB. And what happens is the host is supposed to refresh that file every 5 seconds. It doesn't necessarily write something to it, it just basically touches the file saying, I'm still here, I'm still here, I'm still here. So in order to determine if this host is really failed, the master goes out to that data store, to that file, and says, has this been refreshed in the last 5 seconds? Queries it twice. If it finds that it hasn't been refreshed in that interval, then it determines that the host is not able to heartbeat, it's not able to be pinged, and it's not writing to data stores. So good chance it's just not alive, probably purple screen to death or somebody powered off or something else. If those 3 conditions are true, then the host is marked as failed, and the VMs are then powered on another host. The order they're powered on we'll talk about in a minute, but it's a really critical concept that all those have to be true for it to be failed. If the data store comes back as live, then it goes to isolated, and we'll talk about that in a second. The other thing that's really, really interesting about this, in my mind, is that that file that's created, host-unip unique ID-HB is unique on boot time. So if the host gets rebooted, it will come up with a different host name, --unique or host-unique ID than it had previously and start writing to that file. So when the master goes out and says, is host XX5 available? Well, no, because we just rebooted it. It's now host XX7. So that's how that works. Have we got questions on that?
We do not. However, we do have a follow-up to the previous question. Graham was asking, can you tell it, this is for the first one, which data store does it use, the heartbeat one? Can you actually tell it to which one can it use, or is it always automatic?
I'm not aware of a method that is user exposed to be able to force where the protected list goes, other than VMware wants to pick the data store that is accessible to the most number of hosts, that is.
Gotcha.
But I'm not aware of it. So that's a deeper question for VMware. Start to get into stuff that I can't necessarily answer sometimes on that.
Understood.
All right, so let's talk about what happens when a host is isolated. This is the second state, and this is if it will first check for a failure, and then if it stops seeing heartbeat on the HA network, this is the 1 second heartbeat from the slave, and it cannot ping the host, but the data store is live. It is still writing to that file and potentially other files on the data stores. Then the host is marked as isolated. Okay? And there's a whole discussion around host isolation response we're going to get to in just a minute. But let's talk about partitioning first. A host is partitioned if it stops seeing the heartbeat and can ping at least one of the host isolation response addresses. So this is a host side thing. What happens is, notice that I said here that cannot ping a host isolation address or addresses. This is because you can have up to 9 addresses that you want the host to ping. This is basically upstream routers, other things, whatever you define. By default, it's the default gateway of the subnet that the management network is in. If it can ping it, if it cannot ping it, then it considers itself isolated. If it can ping at least one of its isolation addresses, then it's considered partitioned. Now, partitioned is a particularly scary situation because you can have a couple hosts that are partitioned, and then a new election happens, and those hosts that are partitioned now create a master, and on the other side of the partition you have another portion of your cluster that thinks it's got a master, and everybody's trying to restart their VM. So there's all kinds of split brain problems that come up with that. For this reason, it is really critical to make interesting design decisions around what your host isolation address or addresses should be. By default, again, it's the gateway of your network, but depending on your network topology, you might choose other things like DNS servers or things outside of that network. It really depends. I've seen the multiple addresses used most often in metro clusters, where you want one side can definitely be partitioned because it's at a totally different site, even though you're stretching your cluster across that distance, and you'll end up using it. And then there's the host isolation response, which we'll talk about in a minute. But essentially, you want to be very predictive about what you choose as your host isolation address, because if any one of those addresses comes back with a successful, it's considered self-partitioned and not isolated. I'm not sure that partitioned is something you want to have a lot of the time. I can't think of a situation where that's necessarily a positive thing, unless it is like a metro cluster or a stretch cluster. So let's talk about isolation responses. So when a host discovers that it's isolated, this middle condition, it has 3 choices. The vSphere 6 changes the name of one of these. That's the last one we powered on, so we'll get to that. There's shutdown and restart. This uses VMware tools to guest shutdown and waits 300 seconds. If in that time the guest OS doesn't shut down, as in doesn't issue I/O rights to the data store, then it's just going to power it off and then force it on a new host. This is particularly useful if you want to make sure you have a clean shutdown, but it also means that you're going to have a 300-second delay before your HA failover or your machines are powered on another host, potentially. Second condition is power off and restart. That's literally just pull the power from the VM. Depending on your storage situation, you may want to do that. And then the new one, which is called do nothing, I believe, in vSphere 6, or used to be called leave powered on in 5, is literally do nothing. So there's lots of VMware religion when it comes around which one of these to choose. In my experience, it really depends on your situation. I like this graph. This was first coined by Duncan Epping, and so I'll give him credit for it, and Frank Denneman. But essentially, the less reliable your network is, while the more reliable your storage is, you're probably going to want to choose leave powered on. If you happen to have a very reliable network but a very unreliable storage, you might want to choose shut down and power off. The concept being that if you are isolated, depending on your topology, it's a good chance all your hosts are also isolated. And if that is true, then you really don't want them trying to shut down and power on other nodes in the cluster, because you probably have just lost your upstream networking. You can't ping the host isolation response, can't ping each other necessarily, but they're still available. So I want to wait till my networking is fixed and then just have my VMs resume where they started. Now, if I've lost connectivity to my storage, again, I don't really want them left powered on, because they're writing to cache and they're likely to be in a bad state, and I'm now losing data. I'd rather have them be down, have the customer have to resubmit the data. So shut down and power off might make sense. It really depends on business needs, business requirements, and topology. So there isn't an easy, I can tell you do this all the time. I've seen all of these used in enterprise, and I use all of these in enterprise customers all the time. A couple advanced settings that have application here, because remember we were talking about advanced settings, is DAS heartbeats DS per data store listed right here. This is the number of data stores that we want to use for heartbeat. By default, it is 2. It can be up to, I believe, 8. You can list there. And the concept here is to allow you to select more data stores for redundancy purposes, or because you have a more complex solution. Inside of that, inside of HA, which we'll show in a minute, you can choose which data stores it has to be on or which data stores it should be on. So you get that choice as well if you do more than 2. The DAS allow network X, I believe. Hold on 1 second, I'm looking at my notes on that one. So I don't, I just killed that. One moment, everybody. Okay. The DAS, the allow networks allows you to specify which management network to use by HA. X is a number between 1 and 9, and it basically goes to your VMK next. Again, it's ignored if you're using vSAN, because vSAN will become the heartbeat data store network. The DAS ignores insufficient heartbeat. That's if you only have 1 data store. HA requires 2 by minimum, and you want to have not the alarm come up, but you can't use HA. You can disable it there, and that's how that's done. Isolation, 2 settings that have the most meaning here is the DAS use default isolation address. This allows you to choose to use the default address, which would be the default gateway of the management network, or not. If not, then you need to have these settings, and it can be 0 through 9 to define a total, or 0 through 9. So a total of 10 potential isolation addresses that you can ping. So, any questions on this before I go to the next slide?
Nope, we are good.
Okay, so we got a lot of the basics in. I bet this is a review for everybody. Let's talk real quickly on a diagram. As you can see, I've got a bunch of ESXi hosts. I got some shared storage. We're going to assume fiber channel because it doesn't go across those switches. We've got a tiered network of 3 switches here. So let's talk a little bit about the scenario. If I lose this link, and let's assume that ESXi is my master. If I lose this link, and the gateway for my net management network is switch 3, assuming that they're all on the same management network, then all the guys here are going to consider themselves potentially isolated, but then they'll come back as right there, while these guys are going to still be able to ping and go, oh, I'm fine, I'm okay. And they'll elect a new master because they can't talk to the master and assume that he maybe failed. So, you know, depending on your topology, you're going to get into a lot of interesting scenarios where if the link right here fails, these guys are all going to say, hey, the master's not pingable anymore. Let's elect a new master and move on. While loss of vCenter doesn't affect HA. This is a key component. HA is ESXi host based, not vCenter based. It does interact with vCenter, it does use vCenter, but in order to fail over a VM or a failed load or to be able to take action, that's an action that the master and the individual ESXi hosts do. So you can run vCenter on one of these ESXi hosts, have it fail, and have it come up on another host because HA will work without vCenter. All right, VM restart. We talked about the power on file, and it's asynchronously read every 30 seconds. That's the file that lists which VMs are currently powered on. That's stored on the data store again. So we have a restore priority concept. This is where we list VMs to restart in a specific order. This order is just for the initial action. So if I say I have a high, medium, and a low, it will attempt to power on another host all high VMs first. But the second it issues the power on command, it's going to move on to mediums. It doesn't wait for the operating system to come up. It doesn't wait for anything other than power on. So it'll keep going down the list. And then there's a disabled restart priority, which means it will not be restarted. So when HA does its restarts, it takes into account all of these various things that you're going to look at right there. Most of them make sense: compatibility, capacity available, the vCPUs and virtual machines on the host, restart latency, power on per host is 32 at VM at a time. So a whole bunch of stuff there, but essentially it's going to check that there's room on there for it. It is not concerned about wise placement when it does a fail event. It is going to gather every set of resource it has and shove it onto the machine. So if it can fill it to 100%, it's going to go ahead and do that, then move on to the next one. It's not going to do a DRS. It's going to let dynamic resource sharing do that later. The DRS will take care of it later. It's not going to do that initially. It's just concerned with bringing back virtual machines. All right, so we do have a scenario where we can have a master fail or a slave fail. Here is the timing. I believe this is the same for 6. It was definitely this for 5 and 5.5. But essentially, if a slave fails, you've got about 18 seconds, roughly, until the VMs are restarted on another machine. With the master, you've got about 35 seconds because you've got to get a new master in place to issue restart commands. Nothing more to say about that. The slide deck's being recorded, so you can grab the notes off here if you need them. And the source for this would be the vSphere Deep Dive book by Duncan Epping and Frank Denneman, which is a great source for a lot of this information, one of the best books ever written as far as I'm concerned on this topic. All right, so then we've got a feature of HA called VM and application monitoring. VM monitoring is hardly used at all and really should be used everywhere. What this does is it utilizes VMware tools to monitor heartbeats on a guest or a virtual machine. It checks for that the heartbeats are being received by VMware tools, which is really just a crossover across the backplane. The way VMware tools communicates is it communicates through a virtual chip in the hardware back to VMware, back to ESXi. And so it checks for those heartbeats. If they're not received within a set time, then it's going to check that virtual machine for I/O disk and network activity in the last 120 seconds. If it's not receiving its heartbeats and that 120 seconds it's had no disk and network activity, then it's going to initiate a VMware tools restart of the operating system, assuming that the OS is hosed up, which will eventually lead to a power off, power on if necessary. So this is a really great feature to improve the uptime of servers that are flaky, that crash on their own regularly, without having to be involved in it. I can't see a lot of benefit in not doing this, because if your VM truly hasn't done anything on disk and network for the last 120 seconds, it's not doing anything. I mean, really, the basic of operating systems will at least do some writes to the disk during that time frame. Now, application monitoring is essentially a SDK available via the VMware tools to check for application heartbeats. I haven't seen this implemented much, but basically third parties can create a method for monitoring, and then if that monitoring fails with the same sort of custom scenario, then the virtual machine will be restarted by VMware tools and by ESXi. Not a lot of people use it. I'm not even aware of any implementations out there that use it. There might be some closet cases. Do you have any questions, Chris?
Actually, yes. If the CPU pegs on the guest, tool heartbeats cannot get. Actually, no. That was more of a comment. No, I apologize.
Yeah. So that's why you have a secondary I/O check, is because VMware tool heartbeats will sometimes fail, and that's why they added the I/O there. I think is the continuation of that comment, is because even if you're pegged at 100%, you should be writing something at least swapping the disk.
Correct.
All right, so this is a new feature in vSphere 6, so everyone who's on the 5.5 world needs to listen up for about 5 seconds, and then we'll be done with this. This is my favorite feature of 6, honestly. It really is. It's VM component protection. In order to understand what VM component protection does, first of all, I like to call it HA for storage, is you need to understand 2 states. permanent device loss, and all pass down. And the short names are listed right there, as you can see. Essentially, permanent device loss is when my storage array says, this LUN is going away. I'm going to take it away. All pass down is when LUN goes away, but no notification comes from the storage array. And so ESXi doesn't know if it's going to come back or not. And permanent device loss, it knows it's gone. The challenge with both of these is traditionally, all pass down especially is the worst of the two. Because what will happen is the storage array will have a mix-up, and you'll have to reboot ESXi host to be able to get that storage back because it doesn't know what's going on, whether it's there, whether it's down, or whether it's in between. So component protection, if it's enabled, and there is an enabled and there is an issue events. Issue events will just log that a APD event happened or a PDL event happened, and that this is the action we would take if it was turned on, kind of like your test if true kind of situation. But you can also enable it. PDL will automatically fail over virtual machines to another host. So if you have a virtual machine that's running on a data store and the storage array says that LUN is going away, then the HA is going to try to restart those virtual machines on another host that still has access to that LUN. That's the way it works with PDL because it's trying to ensure that the VMs come back up. It's a forced power down and then a bring back up on another host. If none of the hosts had that LUN because the storage array took it away from everybody, then it will just fail HA restarts. It can't do anything if it can't access. All pass down allows you to define the delay for a VM failover period, then terminates either conservatively or aggressively. And this is a kind of an interesting concept. The aggressive versus conservative. What conservative does is it doesn't terminate the VM if a success of failover is unknown. Aggressively terminates the VM no matter what. So think about it this way. If it can determine that there's another ESXi host who has the right networking and has the right data store and has the capacity and everything else, then it's going to go ahead and terminate it on a conservative setting. If any of those things are in question and you set yours for conservative, it will not shut down the virtual machine. It will just leave it there with the assumption that all pass down scenarios, it may come back. If you do aggressively, it's just going to terminate it. As soon as it gets an all pass down, it's going to terminate it and force it over to the other side or force it over to the other host. It's going to shut it down. Just so you know, all pass down currently has a bit of a problem in that what happens is as soon as that path goes away, VMware starts scanning constantly about every second. Is it back? Is it back? Is it back? And it can create a loop that actually forces the host D agent to fail. And so because of that, VMware put 120 second, which is adjustable via an event setting, where it will literally take after 120 seconds of that, it'll just call it a PDL and done with it. And you'll have to reboot to get it back up. That's a protection mechanism because they were actually having hosts run out of memory and crashing on them, and that's bad if you've only lost one LUN and all the rest of your LUNs are available and VMs are running there. So you don't want to do that. All right, so if host monitoring or VM restart priority are disabled, so if I say I don't want to restart, I have no priority on restarting this VM, then VMware component protection can't perform VM restarts. There's some other caveats to component protection. These caveats, again, will probably be something that would be useful for tests. I can't say it will absolutely, but they would be useful. VMCP doesn't support FT. FT machine will list itself as disabled for component protection. Component protection doesn't support vSAN. It just ignores vSAN data stores and PDL or APD events on vSAN data stores. Due to the nature of vSAN, I'm not really sure how you would get a PDL on them. I can see an all pass down, but not to the local, so I'm not really sure even how those would even work on a vSAN because of the way the distributed architecture works. Component protection is not supported on the newest vVol setup. So if you're using vVols, you can't use component protection, and component protection doesn't work at all on raw device mappings. This is because it really can't tell the state of it, and it can't fail over the VM because it doesn't have that kind of mapping. So questions on component protection?
No, we are good.
All right, I jump to the next then, as soon as I get the right focus. There we go. All right, so admission control. I like to call this the best idea that everybody disables because they don't understand it. Honestly, every environment I've been in, they're like, yeah, we turned that off because we couldn't power on VMs. So admission control's purpose is to help you assure that you have the redundancy that you want in your environment. And what it will do is it will literally not make it make it so you can't power on VMs if they're going to violate that redundancy. And so for that reason, and because of the misunderstandings around it, most people disable it. I really, really strongly recommend that you run admission control. I'll give you some caveats on how to do it that will be better. In 5, they opened some real nice doors for this. They continue to do so here. So admission control essentially takes into the concept that you have to figure out how much spare capacity you have. Now, in virtualization, you probably have VMs with 1 vCPU and 2 gigs of RAM, and you probably have virtual machines with 8 CPUs and 192 gigs of RAM. I'm just picking random numbers here, but I've got both of those in my environment, right? So as having those kinds of challenges, you have to figure out how are we going to determine how much space we have and how much we need to reserve. Do we reserve 1 vCPU and 2 gigs of RAM, or do we receive the 192? So 3 methods for doing this. The first one is called host failures. This is the oldest method, along with a failover host. It's been around the longest, and this uses the dreaded slot size. So what slot size is it takes the highest reservation. So if you have a machine with reservation, which we'll talk about in a minute, if you have a reservation, then it's going to take the highest reservation, both on CPU and memory. If you don't have a reservation, it's going to take 25 megahertz and the memory overhead, which is a very minuscule amount, and consider that the slot size. And it's going to take the number of VMs you have and call those the slot sizes. So if you have 20 VMs and you have enough capacity to run 10 VMs per host, you have 10 slots. And so if you tell it, you know, based on host failures, I want to save 1 machine, it's going to save 10 slots across your cluster for that. And if the next virtual machine takes 10 slots itself because it's 8 vCPU and 192 gigs of RAM, then it's going to wipe it out. So slot size is really, really hard to control, to the point where VMware created a whole bunch of advanced settings you can see over here that allow you to adjust your slot size, because maybe you have a reservation for a SQL server that has massive resources and everything else has no resources, and you want to adjust that slot size. You can do it via all these advanced settings. I personally don't recommend using host failures. Again, this is a little bit of a religion, but I'm a big fan of the second method, which was added in vSphere 6, percentage of cluster resources. So this allows you to set both on CPU and on memory a percentage. So if you want to do n+1 redundancy, which is pretty normal, you take 100%, you divide it by the number of nodes, and that's the percentage you need to do it. So if I have 10 nodes, I need to put 10% CPU and 10% RAM in there, and it will literally reserve 10% of my total capacity available on every host. So if I lose one host, then they can all run that 10% that used to be run by the one that failed. That's as easy as it works. It's really easy to dynamically adjust. You just click the button and change it. So if you add more nodes, adjust it up. If you think about it, if you have a 24-node cluster, you really don't have to save a whole lot per node. It gets to be a very small number, but you're still assuring that redundancy. The final method is failover host. This is basically creating a spare host that can't run virtualization workload unless there's been a failure. So we're going to take X number of hosts and say you can't be used to run virtualization workloads, and you're available in case there's a failure. It's wasteful, right? Because now we're not distributing. But there are scenarios where they do this. A lot of hosting providers do this because they have an SLA that says they must have this available. And it's the only way to 100% assure. If you need n+1, then you put failover host equals 1 in there, and you get it. Any questions on admission control?
No, we're good.
All right. So we're going to jump into DRS, but yeah, before we do that, let me jump into the quick demo here. 1 second. And yep. All right. So always good to do a little bit of demo. I'm logged into the web client here. Let's do the HA really quick. I'm selecting a cluster. In my case, it's a cluster of ESXi hosts with a couple VMs on it that aren't doing anything. HA is currently turned off. I click Edit. I turn on vSphere HA, and then I've got protection against storage connectivity. This is component protection that we talked about, so I click that. Virtual machine monitoring, there's the application or the only individual virtual machine. I'm going to go ahead and turn that on. And then we've got the failure condition against various things. There's a default restart priority. These can be adjusted per virtual machine. I'd leave it on medium unless you have a reason. Response to host isolation. Disabled, which means leave powered on, shut down and restart, or power off. Those are the three features I gave you. I'm going to leave disabled. I'm going to leave mine powered on. Response to a PDL. Issue events or power off and restart VMs. You get to choose that. I'm going to choose power off and restart VMs. Issue to it all pass down. I'm going to go ahead and say aggressive. In my case, so I want to force it down. And this is the delay during an all pass down before I want to take that action. This is critical because remember, an all pass down is the storage array just made the LUN, or the LUN just disappeared. I don't know why it's gone. It might come back. This could be as easy as a switch port flapping or something. So if you want to restart, if all pass down does come back within that time limit, in other words, if the path comes back during that time limit, you're given an option to reset the VMs because they probably haven't been able to write in that time, and especially if you're running Linux, they go read-only if that happens. Windows may be able to recover itself, or just disable, don't do anything. And then there's a slider bar for the sensitivity for your VM monitoring. Remember I said you can adjust it. You'll see there the failure interval, the maximum uptime, and the per VMware resets. It's the number of times it wants to reset, so you can adjust this or set a custom. Read a little bit more about that in the HA guide. All right, admission control. Here's the one that I was just talking about. You can adjust in 6. You can actually adjust the slot size right here if you want to. You can do the slot size gain. This is the one I recommend. In my case, I have 2 hosts. So based on my number, I should reserve 50% of my capacity, so I have an N+1 redundancy. Or you can use dedicated failover hosts and say no VMs can run on it. Or you can not reserve at all, which is basically turning it off. This is the data stores to be used for heartbeats. I don't have any data stores on these, so I can't select anything, but you've got a choice between automatically select, use data stores only from the list, and use data stores from the list, but you know, choose yourself if there's another thing. One scenario I've seen use data stores only from the list is if you have some sort of NFS mount for ISOs or templates, and then you have a maybe a fiber channel backend, you don't want to do that. And then you can select mounting data stores. And then advanced options here is where you insert all of your parameters we've been talking about. So quick run through, but that's it. That's all the stuff. Anyone that wants to play with these, go to VMware Hands-On Labs, select one of the vSphere labs. You can play with it all day long in theirs using the 6 web client and mess it up and then delete the VM 5 seconds later. It's a great way to play with this stuff. Alrighty, let's go to DRS. So, as I talk about DRS, one of the key functionalities of DRS that most people don't realize is they feel that its job is to balance resources all the time. This is not what DRS does. DRS was designed to balance resources during contention. This creates scenarios where you can have one host at 90% utilization on your constrained resource, whether that be memory or CPU, and another one at 12%. And then you start bashing your head against the wall saying, why are you not balancing to, I don't know, 40% per? The reason is because DRS was built to balance resources during contention. It's also built to help have some intelligence about placement of new powered-on virtual machines. DRS is a function of vCenter. If vCenter is down, DRS is, for the most part, down. You can't use DRS functionality. So if you directly go to an ESXi host and power on a virtual machine, it will be powered on that ESXi host, and it will not take advantage of DRS until vCenter is available. DRS talks between vCenter and the VPXA on each XI host. It's a two-way communication that goes both ways. Yeah, a bunch of other stuff here, but essentially DRS is invoked every 5 minutes, or as a host is added to the cluster, or maintenance mode on a host. Those are the times when DRS runs. DRS has a manual, automatic, or a partially automatic setting. Essentially, it can automatically move virtual machines around. It can make recommendations as well as tell you where to place them when they're initially powered on. That's the partially, and then it's disabled. Just don't do anything with them. You have to manually run it all the way. All right, so DRS also, because it is about placement of virtual machines, allows you to create some rules. Essentially, you have affinity rules and you have anti-affinity rules as defined here. Anti-affinity means keep them apart. Affinity means keep them together. Those can be in relationship to numbers of hosts or relationships to VMs. if I have a SQL server and a web server that uses that SQL server and I want to keep them together on the same host for speed of communication because they're on the same layer 2 network, I can create an affinity rule and keep them together. There is also the concept inside of all the rules of required versus should. Required rules means they have to stay together. You want to be careful with required affinity or anti-affinity rules in vSphere 6. The reason is because HA honors required rules. So if I have an affinity rule saying these two VMs have to stay together and they take 200 gigs of RAM together and I don't have 200 gigs of RAM available during a HA failover, they will fail to fail over. So required is kind of dangerous in vSphere 6, unlike previously. Should means they should go together if possible, but you can violate that during an HA event or other scenarios that don't allow it to be together. So be really careful with required rules in vSphere 6, especially around HA, because you'll find that virtual machines will fail. All right, the principal concept of DRS is dynamic entitlement, because when you're trying to figure out how much utilization of resources each virtual machine is using, just taking the allocated resources would be inappropriate, because VMware wisely found out that most VMs don't use the allocated resources to 100%. Hence, the whole point of virtualization is consolidation. So the dynamic entitlement that DRS uses is based upon two things: static user-defined resource specifications. So I'm going to translate that. That is the memory and CPU that you allocate to a VM. Okay? So if you say it has 1 gig of RAM and 1 vCPU, then your user-defined resources, your static-defined resources, is 1 and 1 there. And then there's a dynamic element estimate, and that's based on the level of contention. So we're going to talk a little bit about how that's generated, but there is things, reservation, shares, and limits. So quick definition for those that may not be familiar. Reservation says virtual machine gets these resources no matter what, and nobody can share those resources. It just gets it no matter what. Shares is a process of saying this group of virtual machines or this group of hosts gets this percentage of total resources. So if you have 10 shares in one group and 20 shares in another group, and these are partition numbers, basically it divides all available resources by 30 and then divides it equally. Shares can be useful, but if you're going to do that, don't do shares on virtual machines. Do them on resource pools. Don't do them anywhere else. And honestly, even resource pools, there's all kinds of bad ideas that I can't get into because of time around shares. If you start doing shares and sub-shares, just, you know, I honestly, at this point, I wouldn't recommend using them. There are some use cases for them. And then we get to the worst concept inside of DRS, limits. So limits were created for what I like to call legacy TERDI applications. Everybody's got one, and this is the one where the guy comes in and says that he needs 8 CPUs and 600 gigabytes of RAM, and you don't believe him. So you go ahead and give him that, but then you tell the virtual machine that it's limited to 6 gigs of RAM and 1 vCPU. So the operating system sees that it has 600 gigs of RAM and 8 vCPUs, but it really only gets 1 and 6 or whatever I said. The challenge with this is that you're basically forcing a virtual machine to do the worst thing possible, which is if it goes over the limit, swap at the VMware host level, or just not get its resources. And so in every respect, please, 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 if you learn nothing else, don't use limits unless you absolutely have to. These things will be a killer to you in diagnosing problems. I'll share a quick story. I had an administrator who put limits on a template that we built for a large deployment of Java servers. There was about 70 of them that he was deploying, and one of them got this limit for the template. The limit was 1 CPU and 2 gigs of RAM. Well, they started having a lot of performance problems, so we went ahead and increased them to 2 CPUs and 4 gigs of RAM. Well, the performance problems didn't go away, and we go into Java and it's saying, I've got all that space, but man, every time they started using it, it would slow down horribly. The reason is because the second they would go over that amount and Java grabs all of the RAM available to it, it would start garbage collecting, so it was just swapping everything in RAM constantly to the slowest disk possible, not operating system swapping, but VMware swapping, which is the worst. Having the vCenter host swap it because it doesn't know what's active and what's not. So again, limits bad, please don't use them. Please don't use them. I can't think of a single use case where it makes sense. Even my 30 applications, don't use it there. Please don't. It's just bad. All right. I hit that enough, but you know, I still see people using them. Bad, don't use them. All right, resources. So when it's scheduling to figure out how many resources, because again, we want to consolidate down to what a virtual machine is really using, not what it says it needs or what it's allocated. So CPU is based on percentage of run and percentage of ready plus together. That would be the metric used to determine how much CPU the virtual machine is really using. Memory is based on active memory plus memory overhead, and there's an idle consume memory and times 0.25. I have a slide to explain that. We'll get to that in a minute. I have a slide to explain the CPU. We'll get to that in a minute because it's a little bit complex what we're hitting here. Already talked about those three things. I don't like them. I will say that I don't like any of those three, but reservation is something that creeps up every so often because vendors require it. All right, so CPU shares. Every CPU can be in one of two states, ahead on its cycles or behind on its cycles. So not using what it's allocated or using more than it's entitled or allocated. So as you look at this, we go to megahertz used versus share. This is how we get into that share game. So if we have 2,000 shares allocated to this VM, again, remember I said I would never allocate shares directly to a VM. That's a bad idea. I'm showing you that I did that right here, but let's not talk about that. Let's just use it. So if you get 1,000 share here, right, and it's using 2,500 megahertz per share is that. So what happens is this guy has more shares than this guy. This guy's ahead, so this guy gets slowed down while this guy runs until he gets his fair share of the shares, and then this guy will get his turn. So in this allocation, if they can both be using 2,500 megahertz, but this guy's going to be considerably slower. Another important feature here is shares only come into the game when you have contention. If there's no contention, everybody gets everything they request. All right. So enough on that. Let's talk about memory shares, because this is a super interesting concept. This diagram was partially copied from Frank Denneman's blog, so I'm not going to steal credit from what he did. He knows a lot more about this than I do, so I'm going to give him credit. But remember how I said that there was this concept of idle consume memory. So when you power on a virtual machine, especially Windows, let's assume that you give it 6 gigs of RAM. The second Windows comes up, it says, I want to map all 6 gigs of my RAM. About 2 minutes later, it goes down to what it's really going to use, and we're going to call it 4 gigs of RAM. Or I'm sorry, we're going to go down to what we're really using, which is like 1.5 gigs of RAM. But we've gone up to 4 gigs, and then we've gone back down. And so this distance here is what they call idle consume memory. So they take 0.25 of that, and they add it to the currently active memory, and that is the amount the DRS uses to figure out how much RAM this particular virtual machine is using. It does not use configured size, and it does not use consumed size, the maximum it's ever consumed. It instead uses the currently active memory with 0.25 of the distance between the consumed memory and the active memory. Any questions on that?
No, they're good.
Okay, so from here, if it determines that there is a contention on memory shares, it's going to use ballooning, compression, and swap, which aren't part of DRS essentially, but that's the order it's going to use. It's going to try to use balloon reclamation, compression, and then swap. And then there used to be the page sharing. That's been disabled in 6, so those of you that are used to that, transparent page sharing is disabled by default in 6 because it's considered a security problem. So that's no longer a memory reclamation or memory saving technique. Okay, so let's talk a little bit about HA and DRS together, but before we do that, let me pop over to the demo and quickly show DRS. One thing to look at in DRS is rules. You'll see that I have rules here. I'm going to go ahead and enable DRS so we can do it. So we go to DRS, we turn it on. It is currently set. Remember how I said there's a manual. It'll make suggestions but not do anything. There's a partially automated. This will power on. When you power on VMs, it'll place them on the right host and make a suggestion for that. Or fully automated will power on as well as move virtual machines around. There is a conservative versus aggression migration threshold. It basically tells you how aggressive to be. There is definition of this, but essentially 5 means if there's any gain at all, go ahead and move it, which you may or may not want to do. And then if there's only the really bad ones, move kind of thing. Again, all this only comes into play during times of contention. Otherwise, DRS, it'll move things around, but it won't make the best decisions in such contention. So this allows you to enable virtual machines to choose whether they should be manual, automated, or fully automated. For example, if you have something you don't want moved around, you can disable it. Another feature of DRS that I haven't mentioned is power management. I didn't mention it because most people don't use it. But essentially, this allows you to power off ESXi hosts and then have DRS power them on as capacity is needed. This is usually using ILO or IMPI or some sort of backchannel method. It'll also use Wake on LAN. Almost nobody uses this as far as I can tell. A couple really conservative data centers will use this feature, the power on stuff, but most people aren't willing to take the chances. And this is where you insert additional advanced options just like you did on the other one. Once DRS is turned on, then we have the availability of creating host groups. These are groups of either VMs or hosts. So I'm going to call mine, let's call it host 1. I'm going to go ahead and add one of my hosts to it. And then I'm going to create a group called host 2. And I'm going to go ahead and add the other guy there. Notice how it didn't allow me to select the other one because it's already in a host group. You can only be in one host group. I'm going to go ahead and create a VM group. So we'll call it VM1. And select Photon 1. Photon guy there. VM2. Go ahead and select Photon 2. So now I've created a set of groups. You'll see here. There's, oops, like that. Work the way I want it. Yeah. So I'm going to remove that. Okay, we're going to add that. Sorry, added that wrong. So you can see that I've created some groups and some members. It's interesting that it didn't show up correctly. We'll see how that works. And then we can create rules based on that. Now, you can create rules directly on to VMs and things. So we have choices: keep virtual machines together, separate virtual machines. That would be the anti-affinity versus affinity, and virtual machines to hosts. So if I want to make sure VMs in this group must run, should run, must not run, should not run. Remember, the must run, that's the required, super dangerous. You might want to go with should. I highly recommend it. Then you select a host group, which didn't get created because I canceled out of that too quickly, apparently. So you're able to create the rules and the various stuff in there. And then you can choose overrides here. This allows you to select a virtual machine. And do this real quick here. And choose an automation level for DRS. So disabled or fully automated. And then other relevant settings if they were turned on, like host isolation. I don't have HA turned on, but this is where you change a VM to restart at different priority, like a high, maybe it's my vCenter, or have different PDL, APV, or other settings if it was turned on. That allows you to do the overrides. All right, so jump back into my slide deck here real quick. Wrong one. All right. So HA and DRS. In 5, HA and DRS didn't have much to do with each other because DRS is a function of vCenter. HA is a function of master-slave relationships that is monitored by vCenter. HA is concerned with restarting virtual machines and to enforce availability, not load balancing. So but it does take into account sizing. It will not put a virtual machine with 20 vCPUs and 192 gigs of RAM on a machine that only has 192 gigs of RAM that is 90% utilized. It will try to determine the best sizes available. If the sizing is not available, for example, if you have 20 vCPUs and all the other hosts in your cluster have less than 20 potential physical cores, then it will just fail. It'll attempt to restart it 5 times or X number of times, which can be defined by an HA event setting, and then it'll just fail. Yes, I don't know why you would have mixed clusters with different CPU counts. Honestly, that's a bad idea, but just for the sake of discussion there, I wouldn't recommend it. Again, let me just clarify. Clusters of the same machines, the same class, with the same RAM is your best chance. If you really want to mess with DRS, put machines in there with 72 gigs of RAM with machines with 96 gigs of RAM or something like that, and mix and match your cluster like that. DRS will really freak out because it really doesn't know what to do with that. Because it's going to reserve 10% on the 72 and 10% on a 96. It's a different percentage, right? So yeah, don't do that. As much as possible, you want to have atomic units the same. So admission control may cause evacuation of a host during maintenance mode to fail due to violated constraints. So if you put a host in maintenance mode and you have admission control turned on and it can't assure that whatever it's supposed to protect against, whatever percentage or whatever host failure or slot size you have, it will fail to evacuate the host. It'll just HA fail. So admission control can affect that during the case of evacuation of a host in maintenance mode. It will not, admission control will not stop during an HA fail. So if you've had a failure of a host and VMs are being restarted, admission control has nothing to do with that. It will not stop that failure event. That's obvious because if we want to have N+ redundancy and we've lost our +1, we kind of want the VMs running on everything, even if it's going to mean we're running at 100%. So using DPM without admission control can create a situation where there's not enough available resources for a failure. I think that's self-explanatory, but it's something to look at if you're going to use DPM. And then the host affinity required rules, I think I already mentioned this, will cause HA to fail when placing things. All right, so here's a KB that lists about 300 to 400 advanced settings related to HA and DRS.
Oh, nice.
Most of these you won't use. For anyone interested, get the last digits here. Those that are not familiar with this guy right here, and then just do VMware KB with this number and you'll be able to find it. This is going to have all of them listed, what they affect and how they affect it. Honestly, the ones that I've mentioned today are likely the ones you're going to see on tests, but it's a great reference to have. You know, it gets down to the nitty-gritty. You can do all kinds of stuff. The other thing is this is really good reading if you want to understand how the internal operating of HA and DRS work, because it'll be like, oh, I don't understand why we have to set that setting. Oh, wait a minute, that's why. So kind of nice reading, you know, light reading at the end of the day if you're bored. So that gets us to questions. That covers the entirety of my presentation. I got a few minutes here for questions. Anybody got questions? Let's go.
Let's see. Wait for them to roll in a little bit.
Yeah, I'm going to drink some water for a second.
Yeah, totally. That was excellent.
Somebody's got to try to stump me.
Stump the VDX, part 2.
Yeah, honestly, I'll tell you, I've been stumped every day at my job. There are things I don't know, and I will be the first to admit to anybody, I don't know the answer to that, if I don't.
Well, I think that's part of what happens when you get up there. It's being able to admit that you don't know something is the first step to knowing wisdom, grasshopper.
I'll take your word for it.
No, so I think we're good for the evening. That was excellent, though. Thank you very much.
Thank you, everyone, for joining and listening to me talk.
Yeah, that was spectacular. So I'm going to go ahead and kill the recording now.